So on Tuesdays at this time, I will always, the first part of class, go through your study set and answer questions. And also I have, these are all notes to myself of things I want to make sure I talk to with everybody. So I just want to remind you that part of your grade is attending. So just being here. It could be if you're having trouble with the time on Thursday, if you can come to an office hour. If that doesn't work, we're going to talk about Thursday in a minute, because this week, this is probably, the labs are on Thursday, or the labs are due Thursday, and they're actually worth a lot of points. They're worth 15 points. And that is my mistake. I should have put that in the schedule, that the class was Tuesday and Thursday. So Thursday is optional, but you can also come to office hours. And if either the time of the class or the office hours on Thursday don't work, if you can either talk to me or by email. The lab this Thursday is a lot of math, and that's what I'm going to be doing the last hour of class. And having done it before, you all came in, and so I could work with everybody, and everybody got a 14 or 15 on this lab, or 16, and I still want that to happen. So Zoom actually takes attendance for me, which is a really nice thing. If you do miss like a Tuesday, you can send me an email, and if you could tell me just more than, hey, I couldn't come today. I don't need to know like all your business and stuff, but like a little bit more detail than that. Of course, the days that we have exams are absolutely mandatory. So this study set is due every Tuesday at 10 a.m. It is 5 points, like that's what that says there. And it is graded on that you tried every question. You can see mine right now is blank, so it is 1 point deduction if you do not submit it on time, meaning you decide to turn it in next week or something. I had a student who always turned his homework in late because he liked listening to me go over it, but I don't actually look at it and grade it. You guys self-grade it now. I recommend you actually use a different color so you can see the notes that you write on it. So even if you got every one right, you probably are going to want to add some things that I cover as I go through it. The quizzes. I personally decided I could not handle sitting here watching you all take the quiz. It also wasn't the best use of our time. So the quizzes are now going to be take home. They're going to post on Tuesday morning at 8 a.m. and they are due by 11:59 p.m. They should only take a half hour. For a lot of you, it'll take 10 minutes. They're posting at 8 a.m. in case you want to do it before class because you want to ask me questions. But for most students, they're going to want to go through the study set first. I would say if you do the quiz early, not to upload it until after we've gone through the study set in case there's things you want to go back and look at. I'm absolutely willing to answer questions during office hours about the quiz. So either before class, I have an office hour again today from 6 to 7:30. And so the link is in your Zoom. Let's see. So that's about the quiz. That's about office hours. I wanted to remind you for study sets and for labs, it's 1 point to turn them in late. So this is especially like if you have a homework, it's one of those days you just forgot to do it, something came up, it's 1 point, it's a slap on the wrist. And I do that because I don't want you to just copy all my answers as I'm going through it and submit it and say, woohoo, I got 4 points. I want you to actually do the study sets. This is the best practice you can do for your midterm. With that also, the lab this week is math. It's a lot of math. And I realized this as I was on my walk this morning. I know not all of you are going to be here Thursday to get the feedback from me, and some students struggle with that with this lab. Keep in mind, it's a 1 point deduction if you turn it in late. So if you can only do the first 5, you can actually turn in the first 5 if you want for me to look at, but if you finally finish the whole lab, you can get, you would just lose 1 point. There is actually a bonus on the lab, so you can all still get a 15. So if you do it half-assed, basically, I would rather you wait and come to one of my office hours. I actually do have an office hour now on Saturday morning at 10 a.m. And so my other class, actually, they really like that. It might only work for 1 or 2 of you, but that option is there, and the link is on the Blackboard. The other question was about printing. If you have a printer, it is easiest for me to see things as a printout and that you write on, but that's probably only about half of you. If you don't have a printer or an iPad or something, when you do the quiz, when you do the study set, just do it on notebook paper. For the quiz, because I do grade the quiz on that you get it right, if you can try and keep it in the same format that I show the quiz in. And again, the quiz is due by 11:59 tonight. Is there any questions for me before I start going through the study set? All right, I just keep talking unless somebody stops me or asks me a question. So again, if you forgot to upload it, you should be doing that right now. On number 1, we're just doing physical or chemical. And the only one that is chemical is F, which is the reaction. So if you react or do not react, that is a chemical property. All the rest are physical. Physical, again, are things that you measure, melting, boiling, so changes in states of matter are physical. On number 2, sorry, I have my answer key from before. Melting is physical. Forming, this is copper to copper, that's still physical. Oxidation is reaction with oxygen. So that is a chemical reaction. Filtering, that's just physical separating. Boiling water, that is physical, but boiling an egg, that is chemical, because the proteins, things happen. When you cook, cooking is chemistry, so a chemical reaction is happening. The word combustion is a chemical reaction. That means burning. Yeah, dissolving is physical, mixing is physical, but again, baking, cooking, things happen. That is chemical. So those are the chemical ones. I just pause in case somebody has a question. All right, number 3. A is false, and it should say all mixtures. That would make it a true statement, but how it was originally worded is false. So tap water is a homogeneous mixture. Homogeneous because when we look at it, we cannot see, like salt water is a homogeneous mixture. You can't see the salt in the water, and you can put different amounts of salt in the water. So it has a variable composition. That is the definition. Variable composition just means mixture. All right, B and C are true. So a pure substance cannot be physically separated, and they have a fixed composition. That is what a pure substance is. D is false. And again, it is in all mixtures. So the salt, again, in the salt water, which is homogeneous, the salt maintains its identity and the water maintains its identity. Or the air in this room has nitrogen, oxygen, carbon dioxide. Each part of that is maintaining its identity because it hasn't changed. That question is more just refining the definitions. I wouldn't worry so much about it. All right, number 4. Salt water is a mixture and it's a homogeneous mixture. Homogeneous just means it looks the same throughout with our eyes. All right, B, I'm putting a star because to me, when I wrote the question, a vinaigrette always has floaties. And so all the vinaigrettes that I make and that I've ever had have been heterogeneous. However, the world out there has changed the meaning of the word vinaigrette, and they now homogenize everything because some people, especially small children, don't like floaties in their food. And so I've gone to the store and found them now that there are some that are homogeneous. I avoid questions like this. If there was one on your quiz, I'm aware of that. You can write me a note. Don't overthink these questions. I tried to pick ones that you don't have to overthink, like that one. All right, C is a heterogeneous mixture, and that is because of the carbonation means you have bubbles. And so the bubbles make it heterogeneous. If it was a flat soda, meaning it lost its carbonation, not so much. All right, these next two, D and E, are both compounds. They are made up of multiple elements. So on D, I actually showed you the formula, and on E, I just wrote out the words of the elements. So it's made up of potassium and phosphorus and actually oxygen, but you don't need to know that now. All right, F and G are both elements. Anybody know what the symbol for mercury is?
Hg.
Yeah, who said that?
Anthony.
Anthony. So Anthony, I'll actually give you a bonus point. Can you tell me what SN stands for? Oh, he's on the spot. If you have your periodic table in front of you, which you would as a good chemistry student, it's like right there in front of you. Do you know it, Anthony?
SN is tin?
It is. Its Latin word is sanus, but tin is a sin. I had a student many years ago who would always say that in class. She sat in the front row, and so it kind of became our mantra, and everybody, when I say that, you hear me say it many times. You guys can always have a periodic table with names on it, because I can't control that. You want to learn the first 36 names, not necessarily in order, but I'm going to be using the words and writing symbols, and your brain is going to have to connect them. So it's learning the language of chemistry. So when I say tin, I know tin is number 50, not in the first 36, but sodium and Na need to just become that they're the same thing to you. So Na is the symbol, sodium is the name. All right, yeah, mercury is, I always forget what that name stands for. This is also for me to remind you, there is on your syllabus, it says we're going to do class presentations at the end. This ended up being really fun. I did it with all my other classes in the spring and the summer, and it was really fun. It says you're going to pick an element, and I'm going with that right now, but I'm debating about opening it up that you could also pick a subatomic particle. And look into that and the history of it and stuff, like the neutrino or any of those. And I might be open to other ideas too. But you're just gonna write like a 2 to 3 page paper on it and do like a 3 to 5 minute presentation where you share the screen like this. And again, it was really fun. And so don't sweat it. Yeah. We'll worry about that. That's not for 9 weeks or something. Chocolate chip cookie is a heterogeneous mixture. All right. I and J are kind of tricky questions. I put them on here because they're cool. So gold is the symbol you should all know. So on your periodic table, copper, silver, gold are 3 of the elements that we've used forever and ever. They're all in the same family, but and they are by how much they're worth because of the density. So copper, silver, gold. Aurum is AU for gold. It's actually a name. I've met a couple of girls who are named that. Pure gold is 24 karat. 14 karat means it's been mixed with something. And if you wear gold, I don't have any gold on today. If you look, when people are wearing gold, there's all different shades of gold, and that's based on what they mix in with the gold. So if you go to Asia, they're really into bling bling, like gold, like Hollywood, like really bright gold. There is still the white gold, which is a mix with the alloy that they mix it with. I would not ask you that, but that does make it a mixture, and it looks the same throughout, so it's a homogeneous mixture. It is an alloy. So how I would ask it would be more like it was last week. I did a question. If you see the word alloy, that is a mixture. It is a homogeneous mixture. Brass and bronze are also mixtures. All right. Again, this is on the homework. And so some of this is more for your information. The ones I try to give, you don't run into this debate. A diamond is an element. It is only carbon. I should have asked that as the bonus question. Here we go. I'll give you guys a chance for another bonus. Anthony, you don't get to answer again. You only get one bonus point in a class. So carbon has 3 different forms, and they are called allotropes. So actually, you know what? I'm going to open this up to everybody, so you're not going to answer me verbally. You can email me. You have to email me today. Tell me what this word means, and tell me the 3. Actually, I think there's now 4 allotropes of carbon. And so tell me what each one is. So one is diamond. I'll give you that one. And what the other allotropes are. So my other class, several people have gotten, I sometimes throw these out there, and so you can get a bonus point, and all those bonus points add up. All right. So when you have a day and you don't get something in on time, you're like, I have a bonus point. All right, number 5 is an interesting question. On number 5, I'm telling you it is a pure substance. You're just telling me if it's a compound or element, or you have no idea. It cannot be broken down by chemical means. That is the definition of an element. So B is, I'm going to write, we don't know. B is the definition. PS means pure substance. B is the definition of a pure substance when it cannot be broken down by physical means. A chemical compound can be broken down chemically into something simpler, but an element cannot. All right, on C, the word decomposes means to break down chemically. And so that is a compound. D, no idea. So many things react. Chlorine's one of the most reactive elements. The lecture I'm going to do on Thursday, and again, Thursday I always record. Thursdays will often only be a 1-hour lecture, so the other part of class can be used for going over lab questions and stuff. So either before, so from 10 to 11. And so I think I posted notes for Thursday. All right, and then on E, if it is composed of 2 elements, it must be a compound. And then F, no idea. Lots of things. This gives us really no information. So B, D, and F, more information is needed. All right, any questions on that one or anything on the first page before I turn my page over? All right, and again, this is an email bonus. And all right, let's look at the math. So there's several questions on here that I did not specifically talk about in class, and that's why I put them on the study set to make sure I talk about it with the study set. So you can always try it. You can come in early to ask. Some people did. The idea of exact and inexact. The other quick comment is I sometimes change a question on your study set, and I am sometimes using the one from last year. So if I am doing a question that's not on your study set, if somebody can let me know before I waste all of our time. Exact, means you have unlimited sig figs, so an infinite number of sig figs. And this would be anything you can count, like A is exact, and anytime you have a definition. So an example would be 12 inches to a foot. That is a definition, or 1,000 grams to 1 kilogram. This is going to become important with the math we're going to do after I get through the study set today. So D is an exact number and A is an exact number. The others are all inexact. So what is inexact? Inexact is a measurement like B and C. Or anytime you go like between US to metric. The two systems are different. They were derived in different ways, and we are going to segue into pretty much only using the metric system. And that was the other comment I wanted to make. I said this before class, and if you struggled with mastering metric, which about half of you did, you could absolutely get help with me. I actually went in today and made a note. It was in the very first lecture last Tuesday at 52 minutes. I did a 10-minute talk about how to do the metric, or if you can come to an office hour. There were like 2 people who emailed me. It's easier to do it in office hours, and we went back. So if you totally blew the page or you didn't do it and wrote me a note, you can come to an office hour and we can work through it, and I will give you back part of those points that you missed on that question. All right. Yeah, so the 1.61 kilometers to a mile, that limits us to 3 sig figs. 35 degrees Fahrenheit would technically only have 2. 65 miles per hour would only have 2. So inexact means you have sig figs. We look at that. In word problems, the numbers I give to you are pretty much almost always inexact. The rare exception is when we're counting. And that would be if we're counting like coins, like we have 15 nickels, that would be exact. All right, number 7 is something Tinkerbell forgot to talk about when she taught you sig figs. Sig figs are the number of digits you know, so the known plus 1 more. So plus 1 more digit. This is when you're making the measurement, not the number that's given to you. So the number that's given to you already has the sig figs worked in when you're making the measurement. So if the scale goes to 1 centimeter, you can estimate 1 more digit. So it'd be plus or minus 0.1 centimeter. And if the graduated cylinder goes to 0.1 milliliters, you can estimate to 0.01 milliliters. Next week's lab on density, the introduction talks about this. All right, sig figs, here we go. Woohoo! 5, 4. So this question, zeros to the left of the non-zero are not significant. Zeros to the right are if you have a decimal. So on D, all 5 of them are significant because it shows a decimal. On C, you can give me anywhere from 3 to 5 sig figs. The true answer is it's ambiguous. How it is taught online is that if there's no decimal, the zeros don't count, and that would give you 3, and I would give you full credit. Some people have been taught that they are significant, or that's how their brain works, and they would put 5, and we'd be good. But if I wanted you to only show it with 2 sig figs, we would need to round it in scientific notation. So question number 9 is just me trying to cover 2 pieces of things in 1 step. So for A, we do have to round up to 2.4, and then it would be times 10 to the 4th. So scientific notation, 1 digit to the left of the decimal. and then how many places you move your decimal. If the number is greater than 1, you have a positive exponent. On B, again, we round up to 2.4, but and we move the decimal. It's not the number of zeros, it's how far you move the decimal. So 2.4 times 10 to the negative 3. All right, on C, this is what a lot of students do, and this is incorrect. So I'll put a frowny. They round it to 7, they drop the 200 and they just write times 10 to the third. So anybody tell me why that answer is wrong? Everybody's gonna be shy. All right, I'll tell you why it's wrong. Scientific notation, you have to have a decimal. Only 1 digit to the left of the decimal. So that first one is incorrect notation, and I mention that because several of you did that on your lab. You got the answer, it was mathematically correct, but your answer was not correctly in scientific notation. Every single one of you, I'm pretty sure I wrote a note to you on your lab. So your lab was graded this weekend. And then I wrote a note. If you got a 15, it means everything was great. Sometimes I'll take off like a quarter of a point because there was something I want to make sure to flag you that you say that you go back and look at my note. I personally will not see a note you write to me after I've written you a note. When you post your study set, or I'm sorry, your lab, if you want to write a note to me, you can. I'll see that when I grade it. But once I grade, I don't go back. I have, my spreadsheet looks very different than yours because there's 20 some of you. And yeah, I don't notice the notes except when I'm going through and actually grading it. All right, 2 Sig Figs, again, 7.3. And we only move the decimal 2 places. Again, how I think of it is that the number is greater than 1, like on A, C, and D, you have a positive exponent. If the number is less than 1, we have a negative exponent. When do you use scientific notation? You use it when I specifically tell you to use it, like in this question, and when you start getting really big and really little numbers. We get, we use that a lot in chemistry. Nothing on this first study set is really big or really little. So you did not have to, like on number 10 or 11, use scientific notation. Scientific notation is an efficiency thing. Often once you get to exponents of 4, definitely once you get to exponents of 5, we use scientific notation. And as we go through stuff for the next 2 weeks, we'll look at that. All right, when you have parentheses, it just means you multiply. You multiply and your calculator will give you this answer. You would get part credit on a quiz if you gave me that answer. Does anybody want to tell me what's missing from my answer?
It needs
Units.
to be meter cubed, so units.
Yeah, it needs to have units. And actually, thank you for saying the units. Because most people say Sig Figs because we become obsessed with Sig Figs. That's why I did it as Tinkerbell. Sig Figs is a small piece of this. It's something we need to respect. So absolutely units. When you multiply a unit 3 times, you get meters cubed, centimeters cubed, feet cubed. You cannot have a cube when you add. The unit would just add up. So on this next one, we would just have kilograms. Like on this one, when we subtract, we would just have feet. So adding and subtracting, you just have whatever unit you have, that's what you have. On the last one, our unit, the centimeters, one of the centimeters cancels, not the number, the unit, and our answer is just centimeters. Now, Sig Figs, when you multiply or divide, it is the least number of Sig Figs. This rule we use all the time. This has 5, this has 3, this has 2 Sig Figs. So our answer needs to have 2 Sig Figs. That has only 1 right now. There was no other number, so you actually, this is kind of weird, you add a 0. If there was no other number and you need a sig fig, you add a 0. I left this on the homework to show you that. I don't know that we run into something like that ever again. The other 2 questions that come up with this one, you do not have to show the 0 before the decimal. If you're going into nursing or pharmacy, just get in the habit. They actually do mark you wrong. I've had students come back and tell me that. Engineering and scientists usually leave it off. And then the other question that comes up is some students will tell me, Dr. Sherpa, I didn't get that. I got 8.0 times 10 to the negative 3. That is the same answer. The unit goes after the metric. I don't care which way you show it. I did not specify scientific notation. This number is on the cusp of where you would show it in scientific notation. So either way, my goal for you by the end of the term, actually by the first midterm, is that you're comfortable that those numbers, you would look at them and say they're the same thing. Definitely by the end of the term. I'm going to skip to D for a moment. So again, multiplying and dividing is the rule, the least number of sig figs. So we have 3 sig figs for 2. So my answer needs to have 2 sig figs. So when you punch it in, you get 0.0128. I'm sorry, you get 0.128. The 0 is not significant. It's a placeholder. You have to round up, so it's 0.13. So a couple questions came up before class. One was, somebody said they put it in scientific notation. I would not mark you wrong. So you can write 1.3 times 10 to negative 1. The comment I made to him, and I want to make it to all of you, he said he did all of his questions in scientific notation because he was practicing. And I recognize that is one of my goals, is that you practice to become proficient, and you can do that. What I want to put out there, though, for all of you is more the life message from this. Scientific notation is used by scientists and engineers for efficiency. The first way is much more efficient than the second way. It's a shortcut. Here, it's about the same. And so kind of keep that in mind. So unless I specify, sorry, that's a 2. Yeah, there's on the lab, there's one that absolutely has to be in scientific notation because the answer comes out pretty large, but all the other ones really don't need to be. The other question that came up, and comes up every year, some students told me they actually changed the numbers to longhand notation. So they just took 3,200 times 0.0172 and divided by 430. And you get the same answer, which is fine. However, when you do sig figs, you have to go back to how I originally gave it to you. And so you can only have 2 sig figs. All right, on B, when you punch in your calculator, you get 12.321. And the answer is right, the units are right, the sig figs are not. It is only 12.3, and then the kilograms. So when you add or subtract, it is the smallest, the shortest decimal. That's the easiest way. You can Google fancy definitions, and most people get lost in the fancy definitions. These are terms, so 3 decimal places, 2 decimal places, 1 decimal place. Your answer can only go to 1 decimal place. It's a precision rule. The other way to think of it, so like on C, when you learned decimals, when you learn to add and subtract, you line the decimal up. Tinkerbell would have taught you this. They have to be the same unit, and you get 19.95 would be what the calculator gives you. You can't go past that 7. They actually will show these methods where they show a line. You can't drop a 5. You have to round. So the answer does round to 20.0 feet. So you can't go past the 10th place. All right. On number 11, you are just solving for the Q. I did not say you had to show your work. So you're going to divide by the 360 centimeters and you get, I need to look at my answer, 0.025 centimeters. Again, you do not have to put in scientific notation. If you did, it's 2.5 times 10 to the negative 2. This has 2 sig figs. The zeros are placeholders. They're important. They're not significant. On this one, you're going to multiply by the 2.312 milliliters. So you need to isolate the Q. In all honesty, the reason this is on here is if we cover gas laws are all about algebra, PV equals nRT. We don't do gas laws in Chem 151, so our class is only 4 credits, so we just don't have the time to get to it. And so when you multiply, you get 6.247. 4 sig figs, because both pieces had 4. The unit, the milliliters, this means per milliliter. The milliliters cancel, so you have just grams. And 4 sig figs. You don't have to tell me how many sig figs. You either get it right or not. And then this one, you would add the 0.911 to both sides. And we would get, what would that be? 7.36 meters. You only go 2 decimal places. All right, number 12. It's something I also forgot to talk about in class, and so that's why sometimes I put stuff on the homework. You can always Google it and look at it. And all right, accuracy. This person is not accurate. They are not accurate because accuracy is hitting the bullseye. So so they did not hit the bullseye. It did not get the bullseye, which is the actual answer. That's why the darts are there. So if I went and played darts with Damon, I'm speaking your name, Damon, because you're on top of my screen. So if I kept throwing it and I kept getting these numbers, I never got near 4.72, but I kept getting the same answer. So yes, so we were not accurate, but yes, I was precise. Now Damon might throw where he hits the bullseye, so he's accurate, but his next one goes way off target and the other one goes way off target the other way. So he can be accurate, but he's not precise. He's just all over the place. So precision is repeating. So you get the same answer every time you do it. This is important in lab, which we're not in lab, but maybe someday again. Questions on that one or any of them? And they're all quiet. All right, I'm going to actually stop recording. And that way I